Okay, so this question came from the worksheet from today on calculating periods, and this is from that first section on calculating periods for a simple pendulum in simple harmonic motion. So this question reads, Ganymede is the largest of Jupiter's moon. It is also the largest satellite in the solar system. So we've got a big mass in space that is orbiting Jupiter. Find the acceleration due to gravity on Ganymede if a simple pendulum with a length of 1 meter has a period of 10.5 seconds. So we're going to be using that same formula that we've been using to solve for period for all of our other questions, but this time we're solving for a different variable, which is acceleration due to gravity. Okay, so if we take a look at this formula, we have t. Okay, which is our period. So I'm going to put that over here in our variable side. Our period for this particular pendulum, or the amount of time that it takes to make one cycle through the pendulum, is 10.5 seconds. Okay, then we've also got the length of the pendulum, which is L. So I'm going to go ahead and add that as well to our variables section. Okay, and the correct units for length or any form of distance is meters, so I don't need to change anything there. The time is in seconds, so those are both the correct units for both of those variables, so I don't need to do any conversions for this question. Okay, which leaves me G, which is, I think, what confused a lot of people about this question is usually you've been given G because G is a constant number. However, remember that number that you've got only applies to Earth. So this G, what it really stands for is the acceleration of all objects due to the pull of Earth's gravitational field, which is the same for all objects because their mass is going to make the gravitational pull larger, but it's also going to make their acceleration less, resulting in a constant acceleration of 9.80665, regardless of what your mass is. However, in this question, we're not on Earth. We're on Ganymede. And although it's very big, it's probably not the same size as a planet, which means its pull of gravity is going to be different than Earth's pull of gravity, and it's going to have a different accelerational constant as a result. So that's what we're trying to find in this question, is what is that acceleration going to be on a planet like Ganymede? So we're solving for G in this question. So the first thing that I'm going to have to do is rearrange this formula to solve for G. Okay, so the first thing I'm going to do is I'm going to divide both sides by 2 pi, which gives me t divided by 2 pi on the left side, and then it's going to give me the square root of L divided by G on the right side. So the next thing that I'm going to do is I'm going to square both sides to get rid of that square root, giving me t divided by 2 pi, and then that answer squared is equal to L divided by G. Okay, then the next thing that I'm going to do is right now G is on the bottom of a fraction and we actually don't want it there. So I'm going to multiply both sides by G in order to bring it over here, giving me the formula G times t divided by 2 pi squared is equal to L. Then I'm going to divide both sides by that entire term, t divided by 2 pi squared, to isolate G by itself on the left side. And then over on the right side, I end up with the length divided by that entire term, which is t divided by 2 pi squared. So now all I have to do is plug that into my formula. So I'm going to go ahead and bring up my scientific calculator. Okay, so the first thing that we're going to do is we're going to take time, which is 10.5, and then we're going to divide it by 2 pi. And I'm going to put 2 pi in brackets because we want to divide it by the answer of 2 pi. We don't want to divide 10.5 by 2 and then multiply it by 5. Okay, so we're taking 10.5 divided by 2 pi, which gives us 1.6. Then we're going to take that term and we're going to square it. Then we're going to take 1, which is the length, and we're going to divide it by that previous number that we found to give us an answer of 0.358 approximately. And then because this G is an acceleration, so this will be the acceleration on this planet, our units should be meters per second squared. Okay, hopefully that clarifies that particular question. The only thing that was kind of difficult about this one is knowing that G, although it's constant on Earth, it's not going to be the same acceleration for every other planet in the solar system. So because we've got a planet with a different mass, it's going to have a different gravitational pull, and as a result, its G is going to be different. It will still be constant no matter what orbit or what object we're talking about. If we drop it on Ganymede, this is going to be its acceleration, but it's going to be different if we then go to different planets.